In this module, we are going to see UPS topologies and selection, understanding each architecture's role and limitations. Okay, so that you can do the selection, proper selection or right selection. First is offline or standby UPS. Okay, still we use this. Okay, so what is the working principle? Load runs directly on mains power. Whenever power is there, it directly runs on that. See, these UPS are used in household usage. Like in India, we had power problems. Okay, maybe 10 years ago. That time, even I used to have my own offline UPS in my house. Okay, so whenever power is there, it was directly feeding the power from electricity board, okay, or city power. When it fails, then it takes some time. What happens? Battery plus inverter activate only during power failure. It has a switch. It will switch to, it will sense that power is gone, power is disconnected, EB power, and it will switch on to battery mode only during power failures. Okay, so transfer time is 4 to 10 milliseconds. 4 to 10 milliseconds, even you will not come to know. Okay, so cheapest topology but offers minimal power conditioning. Power conditioning we have seen like sags, swells, okay, harmonics. So all these problems, fluctuations, all these problems are solved by UPS. So this is not doing that. Now, where it should never be used. Okay, servers, no. Why? I'll tell you. Networking equipments, no, you cannot use this. Medical devices or any IT loads. The 4 to 10 millisecond transfer time exceeds most equipments hold up time. All these equipments can hold or continue to work, okay, till what? Maybe 2 millisecond or less than that. So this time 4 to 10 millisecond is good enough to disconnect its function. If its function is disconnected, like medical devices, life-saving devices, then it is not good. Okay, it's like we are not having UPS because it is giving trouble. Another thing, it is not conditioning as well. Power is not conditioned properly. That is why it should not be used. Acceptable only for non-critical desktop PCs which are non-critical. If it is critical, then also it is not advisable. Or basic home equipment. Okay, I told you. FMs often make the mistake of deploying these in server rooms due to low cost. This leads to silent crashes during switchover. So never use this in server room. Okay, these are electronic sensitive devices, very fast switching devices. Less than 4 millisecond time it switches. So it will sense the disruption. Now, second type is line interactive UPS. Okay. AVR, automatic voltage regulation logic, is used in this UPS. So what is that? Uses buck boost, okay, reduce boost, transformer with tap changing to correct voltage without switching to battery. If voltage goes down, what it does, it will switch to transformer. It will switch the transformer so that it can boost. If it is going down, it will boost the voltage. If it is going up, it will buck it. So that is without switching to the battery. So load is still on raw power or electricity board power. We call it raw power. Okay. So handles voltage sags 80 to 90% of normal. 80 to 90% it can handle. If it goes beyond 80%, lower than that, then it becomes difficult for AVR to adjust. And swells 110 to 120 of nominal, okay, normal voltage. So beyond that, it cannot adjust. It has some range. Okay. So battery activates only for complete power loss, not during normal time. Transfer time is 2 to 4 milliseconds. See, transfer time is less in this type of UPS. This is faster. Now, pros for FM use, where to use. Better than offline for fluctuating utility power. If you have fluctuating utility power and you don't have that critical load like server rooms or data centers or medical equipment, then this can be used, because small interruptions or fluctuation is okay in that case, but it is better than previous one. Okay, because it is conditioning power up to some extent, like this. Okay, voltage regulation. So extends battery life by handling voltage variations on mains. So it is handling the voltage variations on mains. So cost effective for small offices and branch sites, not for critical loads. Suitable for workstations and basic networking. Line interactive you can use. Now, cons and limitations where it should not be used. Still has transfer time during battery switchover. Transfer time 2 to 4 milliseconds. Limited frequency regulation. Frequency, it regulates voltage. What about frequency? If frequency goes down, goes up, then what happens? This will not be able to manage it. Okay, so frequency regulation it cannot do. Not suitable for precision loads, which are very important loads like data center cannot, or medical equipment cannot handle severe power quality issues like harmonics or transient effectively. Transients for smaller time we have seen, even microseconds. So these are transients. So this will not be able to manage line interactive transients and harmonics. So we cannot use it for critical loads. Okay.